Ever wondered how AI makes decisions? It's basically doing what your mum does, asking a bunch of yes or no questions until it gets the answer it wants. A decision tree is a supervised learning model that splits data into smaller and smaller groups using yes or no questions. Each question is chosen to narrow things down till it reaches the final prediction. It's basically a flowchart with commitment issues. Decision trees are popular because they're easy to understand and explain, easy to trace the model's reasoning step by step, and they handle both numbers and categories, and they don't need feature scaling. Feature scaling requires math. Trees do not care about math. Classification trees predicts categories. For example, approving or rejecting a loan. It uses metrics like Gini impurity or entropy to choose splits. Regression trees predicts numbers. For example, how much loan to give. It uses mean squared error to choose splits. Classification trees are like detectives deciding, is the suspect guilty or not? Regression trees are like detectives estimating how guilty on a scale of 1 to 10. As an example, we use a decision tree classifier. So in this code, the first line is basically importing the model. This line uses scikit, which is a widely used machine learning library in Python, to import decision tree classifier, which is a model used for classification tasks where the output is a category. We then define the feature matrix. Each in a list represents one sample, which is one data point. Each number inside the list represents a feature. This is the input the model will learn from. After that, we define the target vector. Each element corresponds to the label of the matching row in X. The first label corresponds to the first sample. It contains the truth categories the model must learn to predict from. We then initialize the model. This line creates an instance of decision tree classifier. At this stage, the model is untrained. It has no knowledge of the patterns in the data. It's simply an empty structure waiting to be fitted. We then train the model. .fit means learn the relationship between X and Y. The model analyzes the features and determines which splits, which is the questions, best separate the classes. Finally, you make a prediction. This line asks the trained model to predict the label for a new sample. Decision trees feel human because they use decomposition, a core computational thinking skill. They break a big mystery into tiny clues. Trees use greedy splitting. The tree always picks the best question right now, not the best question overall, just like a detective following the strongest lead first. And this is why trees can memorize everything and overfit. Overfitting is when the tree memorizes every tiny detail, like a detective who overthinks and starts suspecting everyone. But decision trees have a problem. They overthink, like me at 3 a.m. Anyway, so in the next episode, we will look at random forests. Basically, a whole squad of detectives working together. Unlike a real group project, these ones actually do their job.